Hello, and thanks for mathing with me today. In this video, we're going to talk about slope. We're going to define, identify, and calculate slope. A rate of change is a ratio that compares the amount of change in a dependent variable, which is usually your y variable, to the amount of change in an independent variable represented by x. When that change is constant, we call it slope. There's many ways to think about slope. We usually use the variable m to represent slope. And a lot of you remember rise over run, or the change in y over the change in x. Or when we're talking about points, we have y2 minus y1 over x2 minus x1. So the rise is the difference in the y values of 2 points on a line. So if we look at our point here and our point here, we see the rise is there. And the run is the difference in the x values of 2 points on a line. So if we look at our 2 points here, we see that the difference in the x value is here. And then the slope of the line is the ratio of that rise to run for any 2 points on a line. And that's where we get this equation m equals y2 minus y1 over x2 minus x1. There are some things that we can tell about the slope just by looking at a graph of a line. We know that a graph has positive slope, or a line has positive slope if the line rises from left to right. We know that a line has negative slope if the line falls from left to right. A horizontal line has a slope of 0, right? It doesn't rise or fall from left to right. And then a vertical line has an undefined slope. So let's try some examples. First, we're going to describe the slope, either positive, negative, 0, or none. And then we're going to identify the slope using the graph, finding that difference or change in y over the change in x. So first we see that from left to right, this line has positive slope because it rises from left to right. So now we're going to use that formula we have for slope, m equals y2 minus y1 over x2 minus x1. So when we're talking about those values, y2, y1, x2, x1, we're actually talking about these points that we see on the graph. So our 3 would be our x1, and our 4 would then be our y1. And then the other point, our negative 1 would be x2, and negative 4 would be our y2. So basically, we always need to make sure that our x2 and y2 come from the same point, and then our x1 and y1 come from the same point. Which point is 1 and which point is 2 doesn't matter, as long as the first values come from the same point in our equation, and the second values come from the same point. So to calculate the slope here then, we have m equals, so we have y2, which is negative 4, minus y1, which is 4, over x2, which is negative 1, minus x1, which is 3. And that's going to equal negative 8 over negative 4, which simplifies to 2. So our slope of this line is 2. In this next example, if we remember back to when we were looking at the previous lines, when we were talking about positive, negative, 0, and none slope, we see that this is a vertical line in this example, and so the slope is undefined. So let's calculate and see what does this mean, undefined slope? So let's look at m equals, let's call this our point 1 and this our point 2. So when we have m equals y2, that's our 4, minus y1 is minus negative 4, over x2, which is 3, minus y2, which is 3. That gives us 4 minus negative 4 is 4 plus 4, which is 8 over 0. And what do we know about dividing by a negative number? We know that it's undefined. So this is why our slope then is undefined. In fact, I don't even like this use of the word none here, because no slope kind of is similar to 0 slope. It would be better to write undefined slope. Now it's your turn to try. Pause the video and describe the slope of the line and then identify it using the points on the graph. Hopefully you pause the video and we see in this first example number 3, from left to right, the graph falls, and so it's a negative slope. And then if we can verify that it's negative by when we calculate, and we get a slope of -1. And then in number 4, we see that the graph neither rises nor falls, therefore it's a slope of 0. Sometimes we're not given a graph, but we're actually given points, and those points can come in the form of just a pair of ordered pairs, or they can come in a table, which we know that every single one of these is an ordered pair on a graph, and therefore we can use any 2 points to calculate slope. So we calculate it in the same way, m equals, and if we want, we can signify points 1 and points 2. So m equals y2, which is 1, minus x2, which is 5, over x2, which is 8, minus x1, which is 2. And that simplifies to 1 minus 5 is -4, over 8 minus 2, which is 6. So we have a slope of -2/3. Let's do another one. In this one, I'm just going to call this point number 2 and this point number 1 to show you that it doesn't matter which point you call point number 1 or point number 2. So let's calculate. M equals y2, which is -2, minus y1, which is -2, over -2, x2, and -2 minus x1, which is 7. So we get -2 minus -2, which is 0, over -2 minus 7, which is -9, and this slope simplifies to 0. All right, in number 7, we have fractions. So I'm going to just label x1, y1 like this, and x2, y2 like this. You can also just show you another way to label your points so that you don't get confused sometimes. And this one is a little more complicated, having fractions. So we're going to subtract our y2, which is 2/5, minus our y1, which is 7/5, and that's going to be over, this is called a complex fraction, over x2, which is 1/4, minus 3/4. So this gives us 2/5 minus 7/5. Remember, when we're adding and subtracting fractions, we add or subtract the numerator, and the denominator stays the same. In this case, we're lucky that the denominators are already like denominators. So we have -5 over 5. And then we have 1/4 minus 3/4. 1 minus 3 is -2 over 4. Let's go ahead and simplify our fraction. In the numerator, -5 over 5 simplifies to -1. In the denominator, we have -2 over 4, which simplifies to -1/2. Remember that when we divide by a fraction, we reciprocate and multiply. So I find it easier to write it horizontally. -1 divided by -1/2 would be -1 times -2, which simplifies to +2. We took up a little bit too much space there, but hopefully we have space to complete number 8. In number 8, we are going to I'm going to circle the points that we're going to use. I like to pick the smallest numbers, right? So I'm going to pick this point and this point. But it doesn't matter which 2 points you pick, because this table of values represents a linear relationship. So regardless of which 2 points you choose to calculate slope, you will get the same slope. So m equals, and we're going to say -5 minus 3 over 1 minus -2. Oh, sorry, -1. So -5 minus 3 over 1 minus -1 equals -8 over 2, which simplifies to -4. So in this table of values, we see a slope of -4. Another way to calculate slope using a table, and I'm going to do this in blue or teal, is we can just check what is the change in x. So we see that the change in x is equal to, from -3 to 1, we added 2. From -1 to 1, we added 2. From -1 to 3, each time we're adding 2, plus 2, plus 2. So the change in x is 2. positive 2. And then when we look at the change in y, we see that from 11 to 3, we subtract 8. From 3 to negative 5, we subtract 8. And from negative 5 to negative 13, we subtract 8. So that means that the change in y is negative 8. So when we calculate the change in y, so m equals the change in y over the change in x, that's going to be negative 8 over 2, which equals negative 4. So same thing, right? But we can calculate it sometimes from the table a little bit easier by just looking at the actual change in y over the change in x. Now it's your turn to try. Pause the video and try to calculate the slope using the 2 points and then calculate the slope using the table. All right, hopefully you paused the video and in number 9 you see that the slope ended up being negative 1. In number 10, we have a slope of negative 4/5. In number 11, we have a slope of 1/2. And in number 12, we have a slope of 0. And regardless of whether you chose this to be point 1 and this to be point 2, or if you chose this to be point 1 and this to be point 2, you will notice that when you simplify, your slope ends up being the same thing. Well, it's my hope that you learned a little bit about how to calculate slope in this video. Thanks so much for mathing with me.